What is the galvanometer resistance? Resistance offered by galvanometer resistance. Galvanometer resistance by of deflection method. The symbol what we use is capital G, galvanometer resistance. So first, what is this galvanometer resistance? All will offer coil, then knobs, and internal connection. This everything what happen will be the resistance of galvanometer, and we can't find out. It's very difficult to measure all this. So let me go for some basic KCL, KVL what we know. So this is cell, this is a variable resistance, and there's a galvanometer whose resistance I have to find out. There's a galvanometer. Now I'll pass a current so that the deflection, the galvanometer, let it be equal to Ig. I'll notice this deflection. So what is Ig is equal to? You're going to write Ig is equal to E by R plus G. Just go back to Ohm's law, nothing to do. What is G now? Total resistance of galvanometer. So, and we know this Ig is equal to K into that phi. K is what? Called as figure of merit. Okay, now come for this one. What is C by NAB shall I call figure of merit? This C by NAB is what? I'll call it as K. C couple per inch, number of turns. How the current is proportional to angle of deflection from the pointer. So therefore I equal to this Ig equal to K. So what is K? K is called as figure of merit. This is also very important. I should know this. Because what is the reason for that? Couple per unit waste, very difficult to measure. So therefore I'll try to measure using this experiment only. So this is from where? From construction of galvanometer we brought this equation. Okay, got this one? Now what is phi? Phi is inside the galvanometer, the deflection inside the galvanometer. So somewhere I'll show the scale. The pointer will be here. You can go for full scale or anything that one. So this is the phi. Now in the circuit, what I do is I'll adjust the value of R in such a way that, and I'll connect one a shunt in parallel. Now the value of S is so adjusted that the current here, let it flow I. Now this will become Ig by 2. So what is the deflection now? Should become exactly off. So where the pointer will be here. Okay, but able to, I'm able to notice that one. You note exactly that one. Suppose this is 10 milliampere, it should become 5 milliampere. Need not to full scale. Since I wrote Ig, therefore I took full scale here. So I'll adjust now. Now I know all the things. I know R, this is a known thing. And this is also a known thing. This is also a known thing. Which is unknown? This is unknown. How to find out that one? What is I is equal to? See, just simple KCL, KVL. What is I is equal to? Total E R plus this two are parallel, no? GS by G plus S. So what is this current? Off of that total current that is flowing. Off of the total current flowing. So what is Ig? So time being, let me write Ig. Later on I'll write Ig dash by 2. So what is Ig dash? Main branch current into resistance of other branch by sum of these two resistances. Current divider formula. Current through galvanometer equal to main branch current into resistance of other branch by sum of this resistance. So substitute this, no? So Ig dash is equal to, this will be E G plus so 1 G plus get cancelled. So Ig dash is equal to Es by Rg plus Rs plus Gs. Now after this, what is Ig dash? So how much I should make it? It should be off of the current flow, So what should be the Ig dash? The deflection should be off. So what is Ig earlier? K by 5. So how much it should become now? K 5 by 2. Ig dash is equal to Ig by 2, all which is equal to K 5 by 2. Substituting this is equation 1. Put 2 in 1. So therefore this will become K 5 by 2 is equal to, or directly you do one thing. Later on I'll bring it. This is nothing but equal to, or also we can write E by E by 2 R plus G put like this, 2 in 1. So solving this, I'll get expression for E will get cancelled. So Rg plus Rs plus Gs. Let me simplify this. Rs plus Gs is equal to 2Rs plus 2Gs. Anybody? Expression for G? Rs by R minus S. So do we know S? S, the known thing. R is a known thing. I'll adjust it. So now what I do is S, I'll keep it fixed here. R is fixed here. The value of S I'll connect in such a way that the current to galvanometer will become half of the deflection. Then I ended up with a relationship. I'll substitute that one. I'll get the galvanometer resistance. If you know galvanometer resistance, what is the advantage? If you know galvanometer resistance, so tell me, like, can we calculate the figure of merit? Can we calculate figure of merit? I'll come back to this formula. I'll come back to this formula. After getting this is a galvanometer resistance. It is reverse of the parallel, no? RS plus S we used to write, but here a little bit different. Try to do remember. The formula do remember. And now the figure of merit. What is now? I came to know Ig, no? I'll use this two equation. No? So as we know that, now finding figure of merit. Finding figure of merit K. So what is value of G? G I calculated from this equation. So substituting, equating those two, as we know, Ig equal to E by R plus G. Then other side, Ig equal to K phi. So equating these two, K phi equal to E by R plus G. Now you see what is the figure of merit? E by R plus G. Don't say figure of merit depends on EMF offset. This is a finding out. Please, mathematically, you have to control your mathematics here. There's a method of finding out the figure of merit. And now, what is G Galvanometer resistance? I cannot find out. I just determine by this method. And is what applied EMF, what we have put it. R is what I know it. And the deflection is what I'll measure it. So then what happen? I'll come to the figure of merit. So first what happen? I'll find out galvanometer resistance by this experiment. Then after finding out galvanometer resistance, then I'll find out the figure of merit. What is the use of figure of merit again? So what is this figure of merit should be equal to? So you have to go back this entire figure of merit, what you can write it as. C by NAB, no? So C by NAB. What is this figure of merit? Equal to C by NAB. So even these quantities are very difficult to measure. Number of turns, okay. Area of collection, okay. Getting the B bar and C is very difficult to measure. So I'll find out that figure of merit also. Or what should be the figure of merit? Should be very high, should be very low. Current sensitivity, how you define? I equal to K by 5 by K, no? Figure of merit should be low, no? So for high current sensitivity, what should be the value of K? K should be low. Already we discussed, no? This is, so what is the preferred value? Low value is preferred for high current sensitivity. So G using this experiment. So first full deflection, then the value A1 shunt will be connected. That one, the value of S is so chosen that the deflection will become off. Then that value of S I'm going to substitute here. So that 5 by 2 I'm showing it, the deflection. How much it shows deflection? Off of it, it should show in the second circuit here. Like that is value of S is chosen. So you write it here. This value of S is chosen or adjusted. Okay, any experiment, now you can do one thing, say now go back to KCL, KVL. Instead of connecting shunt resistance, can I connect a resistance, one more resistance here? And I know relation between them. Yes, you can do, no? You know enough of KCL, KVL, all the basic laws. Can I do a circuit like this? This what happens for you in exams. Of course, mains, they may not go, but when it comes advanced, no? They may ask you in our weekend exam, not final exam. Final exam, this is not there for syllabus. I can do this experiment in several ways. What do you mean by several ways? I can also make changes in any way, no? The one simplified method I shown. Can I make changes in like this? So there's a one circuit. There's a galvanometer where it is showing deflection, say 5. There's a resistance R. Then can I bring a circuits of this kind? How much deflection? No. There's a full scale deflection. Here the pointer should be the off. The deflection should be pi by 2. So how much of current here should be I1 by 2. I can bring one resistor here and I'll bring one resistor here. Can I do like this? And I'll find out the value of G. Many methods, no? Altogether, the current through galvanometer should become how much? Should become off. Earlier it was I1. Now it should become I1 by 2. Earlier you say I. Some I naught. Need not to IG. Again, I'm making a rule. Need not by IG. Why we don't go for IG? because it may get damaged if a maximum current flows. So I'll go for I naught. A current I naught is flowing. Now I'll make I naught. So I'll get relation between R1, R2. Then I'll ask you to calculate R1, R2 values. You should be ready for exams of questions like this also. Don't just stick onto that formula. I'll give some relation between R1, R2. Then I'll ask you. So from this circuit, you'll get one relationship R1, R2. And one relationship will be given in the question. How much R1 is in terms of R2. Solve those two. You'll get values of R1, R2. Then from that, you can calculate the value of G. It's not only here, I can introduce many resistors, but what earlier I discussed, that is more simplified form than this one. Okay, so this is about the galvanometer. So good theoretical questions are there related to some information. And all that spring, I given some thing, why it should be radial magnetic field. All you have this diagram again, the spring one. So try to understand this one, the use of this one. If there is no spring is there open, nobody will bring it back to the zero position. When current flows to galvanometer 0,